Hi, I'm Andrew Shakes. I'm the geospatial lead at KiwiRail, and I'm in the Capital Projects and Asset Development team. And I started in KiwiRail about a year ago, in lockdown actually, which was quite interesting, hanging out in these surroundings for however many months it was. So our digital engineering team is really new. We actually only officially launched in October last year. We've just expanded. We've now got 6 in our team, and we started off with 2 of us in October. So this is going to be a little bit of a run through of what we're using BIM for at KiwiRail. So there's not a lot of slides. I think I've actually got a grand total of about 1 slide in the whole presentation. The rest are just images and videos. So enjoy. So part of the challenge we have, which is actually a good problem to have, KiwiRail is seeing a huge amount of investment, billions of dollars from government. So we're getting money coming through from the New Zealand Upgrade Program, Provincial Growth Fund, as well as the National Land Transport Fund. And I guess the difference with rail is you can't just detour trains. Bus replacements are very costly and they're very disruptive for customers, including when we're bad neighbours trying to do work at night. Projects have to be very well managed to minimise disruption, so this includes night works, sometimes working on holiday periods like Easter, and sometimes this takes years of planning. And clearly there's a strong demand for doing things a different way. Using VR, we're managing to show what children are actually seeing through their eyes when they're going through a level crossing, which is quite a new experience for us. And as you could see in that little short video, that all they could really see was just the fence, really poor visibility of the train. So that I think led to a bit of a rework of the design, which may have meant using some different type of fencing material. So we have lots of hazards. Not only are there trains, but there's also risk of falling from heights. There's tunnels, which are confined spaces. We've got overhead power lines, underground infrastructure. But we're a very safety-focused organisation. There's very little tolerance for error. Can you imagine the chaos on a Monday morning if there were no trains running? This massive hole was excavated over a holiday period for a new underpass. And they actually used machine GPS control, which actually made the whole process safer and much quicker because they didn't have to have anyone down in the hole, surveying it as they go. Rail, there's a lot of moving parts, real complex and crucial systems like signals. So we also have to manage our documents really well during a project, but also looking back on the project. So the approach we took was just to get stuck in doing the BIM and learn quickly. So adopted existing standards, jumped aboard, sit back and just enjoyed the roller coaster ride. Quickly found that linear infrastructure is quite challenging. There's a lot of tools out there designed for vertical assets like buildings, but we're fortunate to find support, or someone crazy enough to support us on this journey. So we worked with Aurecon to build a platform called GeoDocs, and also with Downer, who were early adopters in piloting the approach with our Trentham to Upper Hutt double tracking project. So GeoDocs pulls together existing KiwiRail systems. So we've got SharePoint, Azure, ArcGIS Online, Autodesk Forge, and it manages the information and workflows according to BIM ISO 19650. I'll go through some of these in a bit more detail. But the system allows internal and external users to have controlled access to a vast wealth of managed information and workflows within the web browser. So didn't have to have any plugins installed or any specialist software. So I'll do a bit of a BIM overview. So BIM, I guess for me, one thing I learned pretty early on is a lot more focus on the workflow from concept all the way through to as built, asset data, and also perhaps a digital twin. And it's really about reuse of information to reduce the rework and avoiding starting from scratch. What we found is that it actually unlocks a lot of other benefits, like anything from community engagement to new ways of working. So I mentioned before, it's a really dangerous work environment that needs to be really well managed. Typically, they would stop trains, or replace trains with buses, or they would not do the work, and they can't really do both at the same time. But what we found was with the use of some clever technology, we're actually able to operate machinery within the live corridor. And this made a huge difference to one of our projects, saving time and money, but also the impact on our customers while maintaining safety. And we think that this is really exciting and a huge opportunity to transform our business as usual operations. And what you can see in the video here is they're actually preventing the machines from contacting with anything within the rail corridor, which means that they can carry on work. Another key theme within BIM is collaboration, and that's throughout the project. We need a lot of collaboration. So that's from sharing files, being able to access the right information at the right time, and I won't go too much into that. But being able to make an informed decision. So I guess an example of that is clashes in a design. So, I mean, underground services is the classic. So we need to ensure that we address all these issues and track them to ensure they're closed out. So this is Revizto. In here you can flag issues and then assign those to someone, track it and close it out. So they might end up redesigning it before we go out to construction. And it's really visual, easy way to explain to people in 3D. We're finding this probably is the biggest growth area in terms of interest in our team at the moment. I mean, contrast to doing this the old way with 2D plans, there's a high risk of missing something, which would lead to a lot of surprises out on site. You know, your digger operator finds a pipe in the way, they go back to the drawing board, and you end up with a contract variation, which costs money, and there's delays. We just can't afford it. So where does ArcGIS fall into all of this, I hear you asking? So in the video, you can see this is a point cloud scan for the PACE project, which is allowing for more trains on the Capitol line. Really, this is just about visualizing and democratizing information for all users to see. So within each project, there's a dedicated ArcGIS Online visualization for 3D models and point clouds. And this really just allows anyone in the project to go in and visualize the current and future states of the rail corridor. So they can take measurements and see the project in context with the surrounding geography. I'm sure plenty of you understand what I mean. So the point cloud scan of the network is probably our default sort of starting point for a project. We also have a panoramic imagery tool, which is really handy for reducing site visits, which are really heavily restricted in a rail corridor. Each user has a ArcGIS Online license. They authenticate using their Windows account with a single click. The next video is showing the as-built information under the tracks as it's being constructed. The information's captured from the excavators as they go. We get monthly uploads to GeoDocs as part of the contractor's claim process. So under the hood, GeoDocs is reading a web scene from ArcGIS Online, and all the content is hosted in ArcGIS Online. And currently it's a bit of a manual process to get point clouds in there using FME, and then I upload using ArcGIS Pro as a point cloud scene layer package. I've put a handful of 3D buildings in there, but I found that generally the level of detail is too high for ArcGIS Online, and there's no sort of easy way so far of removing the internal walls. So in future we might look at setting some standards to make that easier for us, maybe using layers within the Revit files or tags to be able to filter it out. I found the terrain model for ArcGIS Online was a bit problematic at first. The best solution I found was to create terrain models for each project using FME and then share it using ArcGIS Pro. So I'm taking the lowest values from the point cloud and then combining that with like a 1 meter digital elevation model from Lynn's data service to create a 1 meter DEM and then cache that up and chuck it up in ArcGIS Online. And so I found trenching tunnels and excavations to prevent you needing to navigate underground, which was a bit problematic to begin with, but I know ESRI have made some big improvements on underground navigation. So Autodesk Forge, for those of you that aren't familiar with it, allows you to visualize lots of different types of native models in a browser. So, and that's what ESRI have teamed up with Autodesk to enable GeoBIM, which we're really excited about seeing. Within Geodocs, a user can click on a file and preview it using the Forge viewer within their browser without needing any plugins or any software installed. So FME can read most formats that we're frequently using. Some of them need converting to a friendly format first, like Navisworks federated models. Can't be read directly, but you can convert parts of it to like DWF. For ESRI, I'm typically writing to FileG database multi-patch format for the 3D models, and then I use ArcGIS to cache it and share it. ZLAS seems to be the most ESRI friendly format for caching and sharing point clouds without filling up my hard drive too quickly. Although Revizto and Recap prefer LAZ. So in terms of next steps, our team's expanded, so we're now rolling out this BIM kind of approach on all of our capital projects. We've got a big uptake in Auckland. There's a lot of activity out there, especially driven around the city rail link. We've got new ferry terminals in Picton and Wellington to accommodate the new ferries in 2024. There's some traditional BIM elements to that, but with the mix of rail and maritime in there as well. There's huge potential to transform our business as usual kind of operations. This is going to be a bit of a slow burn. We need the business to somehow update the model as assets are renewed and maintained and replaced. We're really keen to explore this ESRI GeoBIM, which is the Forge viewer within the web scene. So hopefully you found that useful, and thanks for watching.